Hello, everyone. I know I'm like Lady McLeat face. I hope I make up for it and like offering something of value. All right. Good. Did any questions come up over the break? All right. Then in that case, let's get going. All right. So some common logical fallacies that I've noticed. So I started noticing the first 10 years I taught, because I was like a first gen undergrad, and I felt like professors just thought I wrote bad and they didn't want to help me learn how to write better. And so I just decided to have an infinite rewrite. And so I got kind of super intimate with sticky logical fallacies. In other words, earnest, smart, motivated people who want A's desperately. I could not unstick their logical fallacy, certain logical fallacies. So I started giving a quiz testing, for example, the difference between a fact and an argument. And it turns out I spend 2 weeks on that topic in every single class I teach since 2007. And still I give a quiz testing that. And the average score is a B minus, you know? So I went to the, this is a long time ago, so this is not the people currently in that position, but I went to the vice chancellor of undergraduate education. And I said, so I really think, what would be great is if we offered a logic class to every undergraduate that made some of these logical things clear to people. I said, for instance, it's my sense that sending social scientists over to learn facts about chemistry in order to learn science might, where they do a lab and they're supposed to get the right answer, might not be teaching them the nature of science. And then you send science majors over to American government and have them learn facts about American government. It's not helping them understand the nature of science, right? And she told me I was an idiot and threw me out of her office, basically. I mean, it's a little bit of an exaggeration, but only a little bit. And I was just like, she's like, I don't believe you that people don't know the difference between a fact and an argument. And, you can come up with 1,000 examples where scientists have gotten this wrong. And a big one is, I don't know if you remember that at the beginning of COVID, the WHO tweeted out, fact, COVID cannot be airborne. That tweet has not been taken down, despite it, at least it used to have a Twitter warning saying this might be misinformation, and turns out that fact that diseases cannot be airborne and that the only disease that can be airborne is tuberculosis has been written into every medical textbook since the 1950s. And it was caused by the fact that two scientists at Harvard didn't like each other in the 1940s. And one of those people kept trying to show that diseases could be airborne, and finally really solidified a perfect scientific experiment that diseases could be airborne. And it happened to be a convenient sample of tuberculosis. It was just it just happened to be the situation to set up a really good experiment happened to be in tuberculosis. So I don't know if you've ever traveled or lived abroad somewhere, but you have to get a TB test before you go. That's because of this fucking fight between these two doctors at Harvard that didn't like each other. And the one guy did not believe the other guy's evidence and said, fine, I'll concede the tuberculosis thing. Well, it just so happens that tuberculosis infects deep into the alveoli, where it has to be, it's a very small disease particle that has to be 5 microns or smaller. And so they just wrote into every medical textbook that if the disease is bigger than 5 microns, it cannot be airborne. And nobody has ever wondered about it or been curious about it ever since. And so when the WHO tweeted that out, the aerosol scientists who work as physicists had a meeting with WHO medical doctors and epidemiologists, and they said, dude, look, stuff that's 300 microns can be airborne, you know? And the WHO screamed at these people and threw them off the call. Probably because they were women, but maybe not, you know. I don't want to prejudge, but it feel, you know, and everybody else was like, you realize that you just threw like basically a Nobel Prize winning, you know, candidate off the call, you know. And so they're like, you know, and it took an open letter signed by a bunch of scientists to try to get their attention. And, you know, it turns out to be a complete misunderstanding all this time, that they mistook the size of tuberculosis, the size of where tuberculosis has to take root in your lungs, with the size of the particle that could be airborne. And medical scientists don't often talk to aerosol scientists. And so they literally had not updated their information. Some other examples of this is Fisher was one of the 20th century's greatest, if not the greatest, statistic, you know, professor, insisted his entire life that he could never be persuaded that smoking causes cancer. Could never be persuaded that smoking causes cancer, because it's not set up as a, you know, experiment. You can't believe anything that's not set up as an experiment. Observational data is 100% useless. It's dichotomous thinking that either science is a fact or science is not a fact. And like Naomi Oreskes is a famous science historian. She's one of the authors of The Merchants of Doubt, which you should read, or at least read a review of, you know. And she wrote an essay that says, if you say science is right, you're wrong, right? The place of science is in the uncertainty, is where we're uncertain about stuff, right? Science is not a body of facts. And so I tell my students there's no such thing as a scientific fact. And I believe that. But what I mean is that there could be facts within the field of physics, right? Or facts within the field of American government or whatever, but they're not scientific in nature if they're facts, right? It's a logical fallacy. It turns out to be a logical fallacy. So, and you don't have to believe me, but I'm just going to put that out there, that the problem that my undergraduates were having is a problem everywhere, you know, and epidemiologists have it right now with one of my intellectual heroes in epidemiology wrote an essay in the 90s, maybe, that was entitled "In Defense of the Black Box." In other words, he does observational epidemiology, in which he finds patterns like people living near power lines are more likely to get certain kinds of brain cancer, or people live, you know, he does research like that, where they identify pockets where it happens to be breast cancer has really high rates. For instance, you know, there's this big finding that Long Island has really, really high rates of breast cancer. Can you guess what was causing that? Ashkenazi Jews are more susceptible to certain forms of breast cancer. And there's a lot of them in New York. In fact, there's more Jews in New York than in Israel. So like you got a, you know, a high concentration, then you're going to get that. So it wasn't necessarily something in the water. but they found these pockets, and there's they found pockets of brain cancer in certain areas of Southern Ohio. Like there's things like that they find. You can't prove causality necessarily, but you certainly are finding, something worthy of discussion, So it's my hope that one day political scientists will recover the fact that they've lost their minds on experiments right now and saying, well, we're a science, and so we do experiments and causal inference, and this is, and all we do is and there's a ton of like journals who do public opinion who will not accept observational stuff, and not everything can be manipulated, as I have found in my recent survey experiment that turns out to be 100% useless in explaining anything I set it up for. I was trying to manipulate something that's not easy manipulatable, and I knew that, but I thought, well, let's test it anyway. So nevertheless, okay, so so I would get ask my students, okay, make a legal argument, explain to me what the law would be, given a counter argument, given a counter interpretation of the text. And I would get, well, the reason Roe was decided was because we're not, raising people right with religion, or, stuff like that. Or I would get, justices don't care about babies, or they don't care about poor people, or, stuff like that. And so I would get causal arguments. Here's one I get: welfare causes laziness. If your student made that argument, what would you tell them? One of the variables does not vary. Right? If we're trying to explain differences in laziness across people, you can't use a variable that is constant across all people, right? The policy of welfare, would, applies to everybody, even if everybody's not receiving that assistance, So, all right, so there's that. Here's some other dumb things. And I presented this to a group of 100 political methodologists, and nobody came up screaming at me. You should have a theory before you test a hypothesis. That's just wrong. Theories are either true, causality is either true or it's not, right? And so this thou shalt not open the data until you have a fully fleshed out theory doesn't make any sense. That's not what David Savitz would say. He would say, I'm looking in the data and I'm noticing a lot of people are, being diagnosed with cancer here. And until 10 years ago, the medical community refused to collect observational data because they were afraid that it was going to reach out from the computer and bonk them on the head if they thought about a spurious correlation, Now they've recovered their minds and said, okay, well, information in and of itself is not bad. It's like you got to train people to sort through what the correlation might be, rather than pretend that information doesn't exist. Because if you're not collecting observational data, the information exists. You just haven't collected it. Like you just haven't looked at it. The causes are out there causing things. And if we don't have any information about it, that's not, it's not helping us, and the dangers of spurious correlation can be controlled by training people well, rather than telling people not to open their data set until they have a theory. So, I mean, you can believe me or not, but I'm putting this out there and I'm staking my reputation on it, 65% confidence has no value, is not true. It's, 95, it's just the same thing as only 95% confidence has value, or once it's 95% confidence, now it has value. It's not related to the value, people have to know something about a country to study that country or to use that country as a unit. It is true. People get inferences wrong, but it's also true the other way. And not using information, again, is bad for science. Indicators of a concept must be positively correlated. In other words, reliability ought to dictate our measurement scheme rather than us combining reliability with content validity for a measurement scheme. Double-blind experiments eradicate confounders. That's a good one because they don't eradicate confounders. Thou shalt not control for post-treatment covariates. So we'll talk about that today. It's mostly true, but we have to have 45 articles making the same point over and over and over again, overly mathematical, to try to create a rule for everybody that is sometimes wrong. It is sometimes a wrong rule, and I hope to prove that to you today. All right, and the standard of peer review should be, I agree with this. This is how I would have done it. Like, the standard of peer review is that the person didn't get something wrong about the analysis, in some way, or made a wrong inference. Okay. So I forgot I want to do a slideshow a little bit here. So, okay. Wait a minute. Hopefully this will work. Yay, it's going to work. Okay, good. So I've got some animations here. So here I've got a continuum. And on this continuum, what I want to put on it is truth or falsehood. Okay. Correlation is always or never causation is false. And then there's factual knowledge, things that are true. Okay. All right. And then you have non-obviousness, is sort of located in the middle between the two, where you have theories that are not true or false, but they're not obvious. They're things that you didn't think of until you took a comparative politics class, or that, and you want to give people in your job talk, when you give a job talk, you want to give people a sense that, oh my gosh, I am completely convinced by this, and I would have never thought of it. That's what you want to give people a sense of. So the closer you are to truth, to proving something, like if you're in here to do a dissertation that you thought of when you were a freshman in college, then you're losing the battle to get a job, because, it's, the more people believe it's true, the more people are like, yeah, this is how I thought it would have worked, the more people are gonna not want to hire you. So, and you want to avoid false also, obviously, but you don't necessarily want to avoid things that challenge conventional wisdom. And I see that this area to the right of non-obviousness is the stuff that sort of, it's non-obvious enough that people think it's false. And you want to go out there and give evidence that that maybe there's some evidence for this. So for instance, viruses, the idea that viruses would cause cancer was insane to people in the 1950s. And there was a woman from Las Cruces, a Mexican-American person from Las Cruces, who in the 1950s, when Mexican-American people and women in particular had an easy time becoming scientists and becoming accepted in their field, which I'm saying obviously quite, sarcastically, she freaking continued on, like, with her absolute belief that viruses could cause cancer. And you know what? Now we have, because of her work, I mean, literally because of her work, we have vaccines for cervical cancer. And it's entirely because she pushed forward. She lost funding. She was fired from jobs. She was forced to take jobs studying bugs and agriculture and, stuff like that, and would just like climb her way back into, figuring out ways to, push forward on this. And it turns out that if we would have believed her, or if she would have been born a man, she might have done something different with her life had she been born a man. I don't know, but like we might have saved who knows how many lives with those vaccines. And now we know that various herpes viruses, especially the one everyone has, like if you ever got a cold sore when you were a kid, that one caused Ted Kennedy's death, for instance, from a brain tumor. So that, it's like stuff we, thought was crazy is now considered true. Viruses cause cancer in 2023. Completely, everybody agrees that it's a possibility, right? It's a fact that viruses cause cancer. Like nuns who've never had sex cannot get cervical cancer. That's an example. Okay. Quantum mechanics in the 1920s. I mean, I can't remember, some number of hundreds of physicists signed an open letter to Einstein saying the theory of relativity couldn't be true. And finally, he convinced people. And then he was on the list of people who signed open letters against quantum physics, because I don't know if you know anything about quantum physics, but if I didn't know that TVs didn't work without quantum physics, it is pretty hard to believe, little tiny particles inside atoms are coupled. And even if you put like one of the other particles in, New Jersey and the other ones over here in Las Cruces, they know what each other are doing. It just makes no sense. And so, but now everybody knows that quantum mechanics is a fact. But there are aspects of it that are a mystery. All right. We have illogical social science that are factually false. Welfare can't cause laziness if it's a policy that is available to everybody. If I could stop working and get paid money or whatever, which is not the way welfare works anyway, but people don't realize that when they make this stupid claim. If it's illogical, then it cannot be factual. And so it's like stuff like that. You don't want to be there. But over here, closer to factual knowledge is Y equals Y, and that stuff gets published all the time. It's irritating. Here's the stuff where social science models or causality is uninteresting or obvious, or, it's on the closer to truth from non-obvious. It's like education leads people to support civil liberties. Sure, that was true, and that was interesting in the 1960s. It's no longer interesting because we sort of know, Now, if somebody could come up with some way of designating causality there, or like what the causal mechanism would be, then it would be kind of interesting. And here's where social science models where causality is uncertain, defended by less than perfect evidence, yet eventually accepted. Like my finding that divorce causes people to, or at least is strongly correlated with support for political violence, controlling for everything that could possibly be related to those two things. All right, so like that is not out there yet. The stuff over here gets published. The stuff over here can get you some kind of reasonable job, but the stuff over here that is not accepted yet is the stuff that I find the most valuable. Is that it's the stuff that moves it from false to true. None of us believe this. Now all of us believes this. Those are the great scientists, Okay. This means that just because it's got a bigger correlation doesn't mean it's a bigger contribution. You could have a very small correlation and have it be a contribution. And by the way, do you know what the R square is of smoking causing cancer? The R square is 0.01. There's a lot of other stuff that is related to it. And plus smoking, it's gonna kill you, whether you get cancer or not, right? And a zero correlation is not an indication of no effect. Simpson's paradox is one example of that, but maybe you've got a bad measure. Maybe you've got a context in which that correlation is zero. For instance, I had I was a discussant on a group of papers at the Midwest, and they were making the argument that if you look across states that have more women in positions of the not constitutional court, but the Supreme Courts in those states, women have higher support for courts. Because maybe you don't know this, but women hate courts. And this is true in every country. And it's like, they should hate Congress too, but they don't. And so like, it doesn't make any sense to me. So I was like, all right, let me look at my 2016 data and see what the correlation is between gender and support for the court. And I found, well, holy shit, the correlation is zero. And I've never seen a zero correlation. And turns out it's back up. But if you control for party ID, then it's back down. And the argument is that that's when, around the time of the survey, is when everybody was talking about RBG and the notorious RBG, and all the movies were coming out about her impact and stuff like that, that might have had an impact on removing some of that correlation. So I was like, where you need to go next? What do you think I told them where they need to go next? I mean, you know, they're American politics people, which and they're the most irritating people. So they're not going to go there next. But where they need to go next is multi-level models with world value survey that could actually look at to see the proportion of women on national high courts, to see where that is. Because, you know, speaking of mediation models, when I was in grad school, I was looking at this data and I noticed this correlation. And I mean, I went to town trying to find any variable that would mediate that relationship, that would explain why women don't like courts. Is there anything about the strength of their opinion about abortion? Is there anything about whether the court has made an abortion opinion? Is there anything about the court's decisions related to gender? Is there anything? Like, I could not find anything. So I can't publish an article showing, hey, here's this cool correlation. You know, like, there's got to be some reason for that correlation. I was looking for a mediator, so I couldn't find it. Women also less politically tolerant, but less racist. Explain that to me. But the correlation between racism and political tolerance is also zero. So who knows? Okay. So here's some other stuff. So Barron and Kenny, have y'all heard of Barron and Kenny? Have you heard people talk about Barron and Kenny? And they're all like, we don't like Barron and Kenny anymore, and this is why Barron and Kenny are wrong. So here we're going to talk about mediation models, because what happened is, you know, political psychologists were just like having their merry day with Barron and Kenny, you know, and doing causal pathway analyses and stuff like that. And then they came up with really good ways of doing mediation models. And then they came up with what they should have learned in my Data 1 class, which is that these mediation models cannot distinguish confounding from mediating. And so from now on, we can't just assume that just because something has been mediated and you're calling it mediated doesn't mean it's the true mediator, and it doesn't mean that it's not a confounder. It will treat a confounder the exact same way it treats a mediator, that mediation analysis. And I mean, I remember having a grad student 15 years ago who was just like, if it's not been through a mediation model, it's not true. And I'm sad to think where that student is now, because it's like they learned a whole method right before it went out of style. So in any case, so we're going to talk about these critiques just a little bit. All right, so here's something my student found. I had an undergraduate student using the GSS and noticed that they asked height and weight in the GSS. And so was able to calculate people's BMI. I noticed that people's BMI was correlated with all kinds of politically interesting things, you know. And so BMI turns out to be negatively correlated with confidence in science and the medical community. And here it is as an index, and it's created by a bunch of different variables, okay? And everything's at the O1 level. And, you know, we're not running around town talking about this correlation, but it's also quite non-obvious, right? It's not the first thing you think of when you think about what causes people to have confidence in the scientific and medical community, right? I know, here's what I hope. I hope y'all are going, what the hell, right? Okay, go ahead, Matt.
Yeah, I was just wondering for clarification, for BMI, the higher it is, does that mean the less healthier the individual is?
Yeah, the fatter.
Okay.
Yeah. And you know, BMI is now no longer considered a medically relevant variable, thank God. But okay, so anyway, so I'm not complaining about that necessarily, but like I was like, okay, now this is kind of interesting, but okay, so first of all, is there anything that could cause both?
Well, I guess like if I had a quick like assumption on why there could be like causing both would be like non-belief in like healthy food, therefore like leading one to being unhealthy with body. And then what was again the DV?
Okay, so what we've got, what your model is your model is trust in the scientific and medical community causes people to not believe the facts they put out, which then causes people to be more unhealthy. I think that and so that wouldn't be a confounder. That would be a reverse causation, you know, with BMI being a mediator in a sense, right? Which I'm not complaining about your answer, because I think your answer is a really thoughtful one. And it is going to affect this analysis, right? To be able to control for that, right?
In conditions like issues with your thyroid, like thyroidism, or things that like weren't treated for a long period of time, or doctors kept missing. So, like you struggle with your weight because of this, but also it took doctors forever to diagnose it.
So are you suggesting, Joey, that doctors might be fucking assholes to fat people? I mean, I tease doctors, but in a way I don't, because I had been thin my whole life, and I got on this medication that is super well known to cause people to gain weight. So I went to the doctor and I had a couple complaints. One was I had a weird pain in my calf. The other one is I had terrible pain in my knee. And the other one was I was trying to figure out, I'd read the medical journals and they suggested that if you're on such and such medication, that another medication you could get on actually prevents the weight gain associated with this medicine, right? She said, if we had a pill that could cause you to be skinny, don't you think we would have given that to you? And she said, I don't think that swelling around your knee is swelling. I think it's that you're fat. And number 3, I think that you're not exercising enough. And so you've overdone it on your calf. And I said, okay, well, I used to run a lot of marathons, and I know this is not muscle pain. I recognize the difference between this and muscle pain. And she said, well, as I look at it, you've got a really big varicose vein, on your calf. So she rolled her eyes. She said, if you want me to, I'll test and see if you have a blood clot there. Okay. 48 hours later, they called me and they said, you need to go to your nearest emergency room. And my lungs were full of blood clots by the time I got there. Like, do you know how close that doctor came to killing me? You know? And I just had my feelings hurt so bad. I was like, I've never been treated this way by doctors before. And it's like, well, I've never been overweight before. You know, it occurs to me, you know, kind of thing. So it's like, you know, I was just like, so if I, you know, I'm feeling myself get angry about it because I'm like, she nearly killed me. And then it turned out I needed a knee replacement, you know, so like there were all these things that she was just totally fat phobic, you know? And so, now, you know, now I believe people more, you know, like I really believe, you know, doctors kill people because they're Black and stuff like that, because, you know, anyway. All right. So if you had your wishes, Joey, what variable would you like to control for to see if we could do a Barron and Kenny approach to BMI causes X, or let's call it Z, which then causes confidence in science? Like if we push through like our discussion here, that people who are overweight walk around in life being treated poorly wherever they go, right? That people are being fat phobic to them all the time. I mean, I don't know. Wouldn't it be great if we had that variable? Oh, really? Do we have that variable? So here we have this variable. How often in life are you treated like you're not smart? Okay. And turns out when you treat people like they're not smart, they don't trust the science and medical community. Like that, you know, it's like being treated with disrespect. And there's a bunch of other variables like this in the GSS of, you know, are you treated poorly by servers when you go to a restaurant, or you know, are you treated like people fear you, or are you harassed at your job, or harassed, like they're, you know, like I said, this variable is rich, and turns out it does reduce it. And then when you control for both, BMI, the effect of BMI disappears. Now, if I was to try to publish this in a journal, I would be told we don't do Barron and Kenny anymore, right? And so I'm going to just step out on a limb here and say that, first of all, I get it. Barron, the critique of this approach is that it might be that whether you're treated like you're smart or not smart in life, may not be the true mediator. There may be another mediator out there that would also mediate the relationship, that has a more proximate cause, or is, you know, is a better explanation of what's going on. Finding whatever variable in the model is not really getting at our understanding. On the other hand, do you believe, how much do you believe the causality between BMI and being treated like you're dumb? Because I've existed many times in life, overweight and not overweight, overweight and not overweight. And I can tell you, it changes the way people are in the world to me. It's shocking, you know. One time I lost a bunch of weight and I was so stressed out, I didn't notice. And the only way I noticed it was that, you know, people were being nice to me. And I was like, I wonder why everyone's being so nice to me. And I looked down and I noticed I'm a size 4. And I'm like, oh, I didn't realize I lost all this weight. You know, like it affected me that much. So I believe in the causality of both of these things, you know. Now, is that to say this is a full model? It is not to say that. Is that to say we've proven something here? We have not. But this is an interesting, non-obvious explanation that could be a part of another model for what it is that causes people to not trust the scientific community. And it turns out that people walk around who are being treated badly, don't trust experts, you know, who does that hurt? Well, right now it's hurting you all because you all are looking for academic jobs, and those are the, we're defunding universities across the country because we don't like experts. So, Jamila Michener has found that when Medicaid is administered in such a way that allows these little bureaucrats to treat people poorly through their daily life, reduces turnout by Black and poor people by 10% in those states, and so this would be corroborative evidence for what she's talking about, Matt.
Yeah, I guess I had a question. I don't want to derail it again, but like
Yeah.
I was wondering on your perspective then, like in terms of like the finance for like education going down in the US, you think there's like a narrowed down to like social sciences compared to like I don't know, like biology or chemistry, that they're treated still fine, but due to like the political, I know, battle that happens like in Florida and other like conservative states, more of the like the social sciences are being like scapegoated maybe, or like pushed?
I mean, it could be, but it's my sense that, what's her name in Colorado, who is an idiot. Uh-oh, if I ever publish this in public, then I don't mean to, if I were in Texas, I might be fired for that. I don't know. But the person who has said things that I disagree with, who's the legislator in Grand Junction, she didn't like any experts, and I think this goes along with, hey, we know a bunch of stuff and you don't. And does that really happen? Maybe it does. But I suspect that there's a boogeyman in the minds of people that is not actually realistic. And so if that's the case, there's nothing we could do about it. But I suspect that what might be underlying this is, calling people white trash, for instance, is not super good for making them not be racist, just as an example, having been called that lots of times, it doesn't make you feel good, that's for sure, and so it's like there's like a little bit of a joy in getting back at those smart people that might be, underlying what's happening. But y'all should write a dissertation about that. Honestly, it'd be super interesting to find out, All right. So the conclusion could be that being treated poorly causes your BMI, well, darn it. What do? I can go back. Oh yeah, so like it could be that my variable went away. Oh no. So like BMI, being treated poorly might cause your BMI, like we talked about the other day, that like experience with microaggressions causes glucose to go into your system, which causes obesity. So there may be something like that, or there may be something that causes both BMI and trust that could be a confounding factor that we're not clear on. So when you have the mediation of exogenous factors, treating BMI as though it's exogenous is not really fair, right? Because there are attributes of your life and attributes of what you're doing in your life that might cause both your political attitudes as well as your BMI. Like you suggested, Matt, that like maybe they don't believe the information. Me, I believe that Cheetos are bad for me, but I eat them anyway. Right? It's kind of, like that. I shouldn't brag about that. It's not a good thing. Don't follow my lifestyle choices. All right. So the mediation of exogenous factors, remember to never correct when an exogenous factor has been reduced in a multiple regression. You do not correct the estimate of that exogenous factor. if race is mitigated by something in a multiple regression, that does not mean race doesn't matter. And I was trying to find some examples today of like things that sex would be related to. And for instance, whether women belong in the home, you know, there's like this variable that it's better for children if women stay at home and raise the babies or whatever. It turns out that men are more feminist than women are with regard to that attitude. So that's like kind of a funny thing that you find, but also like, you know, women are irritating is this new measure they have for female resentment, that how irritating women are. You know, women are slightly less willing to believe that women are irritating and just want power and control. And that's why they're trying to dominate men and all this stuff. Women are almost as likely to believe that as men. It's insane. I know, Joey, I hope you're like saying, what? Because like, I'm going, what? You know, like what is going on there? And just like people of color can inhabit a white identity, distancing themselves from people of color or other people of color or whatever, women can have a male identity in the sense that they don't think of themselves as men, but they associate with social dominance of toxic masculinity, you know. Like I have a cousin who likes to shoot bears and but also believes women belong in the home. You know, it's like that's a toxic masculinity type thing in my view. So like the problem with Barron and Kenny is assuming that because something is mediated an exogenous factor, that it is therefore the mediating factor. It is the true mediator. And mediators, just like any other variable, can be confounded. Like they, you know, so there can be variables that end up confounding that relationship. So it's important to be aware of that fact. Okay, good. Post-treatment covariates. So I keep talking about this and I don't even know if y'all know what I'm talking about. And it's mostly because I've tried to identify things that have been more recent developments that Anand didn't teach about last time. And when I got into it, I'm like, this literature is irritating because they're all saying the same thing. They're all coming up with a rule and I see through it and I see through all their math and they are right, sort of. And they're more right in certain circumstances and more wrong in certain circumstances, but I haven't found a good article that makes an intuitive explanation for this. So then I decided I would try to do that myself here. All right, so thou shalt not correct estimates of treatments or any exogenous factor, which would be a post-treatment covariate, right? You've got a treatment. We're going to give people a drug, not give people a drug, and then they're going to do stuff. They may exercise more or less, depending on the treatment. And then the exercise is doing some causing that you might want to control for. But the problem is that the treatment isn't the only thing that is causing the exercise. So then you end up over controlling for it. So the don't control for post-treatment covariates is the same advice as don't correct estimates of exogenous factors in a multiple regression. You can compare, wow, the coefficient of race has been reduced. Turns out when I include such and such variable, that, you know, the relationship disappears. It might be a mediator, that would be the way to talk about it. But the problem is that you can over control. And so I'll show you some examples of this. Or any variable that partially mediates or is not entirely caused by the treatment. Okay. Or any covariate that over controls a confounder or any pre-treatment covariates. Because guess what? The multiple regression doesn't know if it's a pre-treatment covariate that is somehow a confounder of the randomization, maybe of the treatment, something like that, multiple regression doesn't know the difference. And you could over control for that. And then you're reducing the effect of the treatment. And that's what has all these methodologists up in arms, is that you control for some factor and it over controls and reduces the effect of the treatment. And now the effect of the treatment is biased downwards, or with Simpson's paradox, biased upwards. Like you can get situations like that. All right. So let's get into the nitty gritty. If the experiment is not perfectly random, then you have to correct for the confounder, but just don't over correct for the confounder. And you want to control for any causes of the independent variable, as long as it also causes the dependent variable. You do not want to control for correlates of the dependent variable in any observational study if you do not believe it causes the dependent variable. Those should not be in there anyway. And if you don't believe it causes both, and it's not part of your experiment and nobody else is going to believe that it causes both, you don't include it in the regression, because it just can muck things up. Multicollinearity just, can destroy your regression. But if a variable does not cause both your dependent variable and your independent variable, and it must cause both, and if it doesn't, ignore it, as long as you're pretty sure it doesn't. But if you think it might, then you want to control for it. But be aware that you might be over controlling, in the sense of absorbing too much of an independent variable or absorbing too much of a dependent variable, that then just leads to multicollinearity and leads to biased downward estimates of what you're interested in. So it's just something to keep in mind. Okay, here I'm joking with the trigger warning, because to me, as soon as I saw this evidence, it ruined my life. Okay, so, and I'm kind of teasing about it, but it was a pedagogical experiment that yeah, it ruined my life. Actually, just this Pearson R. I looked at that Pearson R and I'm like, everything has to change, and I started completely changing the way I teach, which has interfered with my research, yada, yada. Okay, so here's some information. In a study, 10 university study that included Vanderbilt and Tennessee State and University of Colorado in Boulder and a bunch of other universities, Colorado College, that, a bunch of different kinds of colleges and universities are in here. It's thousands and thousands of undergraduates. And they administered something called a CAT. And the CAT is a critical thinking test that is extraordinarily valid and reliable. And their estimates of an undergraduate's ability to go, wait, what? Like, I see that that's a correlation, but what else could that be? And if you start listing out possibilities and the possibilities make sense, then they get a higher score. So it's basically the ability to think of confounders for the correlation, or to imagine alternative explanations. Okay, that's what it measures. And I was one of the graders on this test when they were grading it. And, you sit there all day and you argue about, does this count for an extra credit? Does this not count? And, it's an extraordinarily expensive test to administer. Okay, but it's valid and reliable. I see it as a good indication that somebody's thinking critically. Okay, so, and you'll just have to believe me. And if you look for just the moment, not in general about anything, but, just for the moment, look at the impact that your freshman year has on your critical thinking abilities. Now, to me, I look at that and it takes the breath out of my lungs, because we're taking 50 grand from people to give them this, you know? And I cannot accept that ethically, you know? And moreover, combine this circle with, I don't know if y'all can see my whole screen. Do you see my whole screen? And just, I don't see it. Yeah, that's what I thought. Turns out the impact of memorization and the ability to do well on this CAT test is negative 34. Okay. The Pearson R between having memorized stuff as an undergraduate deeply reduces your ability to think critically. So people who memorize spend their freshman year memorizing information are worse off than they started before they spent 50 grand. When I gave this presentation, I was like, I've never felt so judged by a correlation coefficient in my life, you know. All right, so yeah, it makes me very sad. And I was like, okay, so everything has to change. And I saw this coefficient around the same time that I was grading infinite rewrites, and I couldn't get people to unstick their logical fallacies. And what occurred to me is that if we're assigning essays, then you know what we're doing? We're giving rich people high grades. We're rewarding the fact that they happen to grow up in a wealthy school district, and we're giving them good grades for having been so lucky, you know? And I can't ethically, you know, participate in this unless we think of something else to do. Okay. So when I saw that and I put those two and two things together, I said, everything has to stop, because that also happened at the same time in one class. Every single person of color dropped my class because of poverty. And those people can't write infinite rewrites because their dad lost food stamps and they had to drop out of school to go to work so that their dad would be able to eat, and that weighed on my conscience as well. It's like, what, like I can't reward people who have time, and so I decided, let's come up with something different, and I fumbled a lot, but I've come up with something I feel like is reasonably good. So then I'm, popping around trying to publish the ideas that I've got, and I've got an essay that I can't get published anywhere, at least not anywhere good right now, because they're like, well, you don't have data. I'm like, I'm trying to collect data, but they told me I can't apply for an NSF grant until I have a bunch of pedagogical research published. If I can't collect data, what and so I'm like, so I've been, soaking in the science education literature, sort of the STEM education stuff. And there's an entire wing of science education that have identified, that is based on identifying what they call student conception errors. And these are errors in the way people reason about the science that they're learning, their ability to visualize, or their ability to just kind of state that, mass equals velocity, like all the formulas that, because it turns out that most electrical engineering seniors don't understand Ohm's law, which is like the basis for all electrical engineering. And it turns out that, for instance, in this one study, 100% of science majors visualized how the planets go around the sun incorrectly, including physics majors. 100% of them. It was a small study, but it was replicated in other places that were also small studies, but 100% is a bad rate, and it's like, what's happening is professors are a different subsample from the rest of society, and they're teaching in a sense to themselves, and they're teaching the way they were taught, and they're not aware of people's misconceptions. So you're stacking information on a faulty foundation. and it doesn't correct that foundation. Okay. So, and the list goes on. I mean, it's an entire field. There's thousands of publications in this area that have identified that. There are 0 in the social sciences, but there are thousands in the STEM education. Okay. So these bioinformatic professors, some kind of 6 or 8 years ago, came up with what they call error discovery correction learning. And I'm so happy about it, because this is what I do. Instead of assigning an essay for my class, I write the essay. And I put factual from the class, like facts that they should have learned from the class. And I put factual mistakes, and I make logical mistakes that I have told them how to identify. We talk a lot in class about confusing should with is, or confusing is with the fact with an inference, and all that stuff I was just talking about. There's a bunch of errors, because for a while I started like keeping an informal notebook about, okay, here's another example where a student made this error. Here's an example where a student made this error. And I have a little frequency distribution that I'm not allowed to publish because nobody's a human subject. But I have it on there, and I use it to guide my teaching. And then I make those mistakes, and we practice in class going over these essays where I've made the mistakes. And I'm not testing them on anything I haven't taught them. So I'm not rewarding students who grew up in good schools, who know how to, write a good essay. I'm, rewarding students for having learned what I'm teaching them, as much of bullshit it might be. I mean, I'm not saying I'm the be all end all. I'm just saying I'm at least trying here, And so what you do is they, instructor asks a question, students submit an answer, students discuss it, then instructor discusses it, then students self-assess, they take a little quiz. Then if they get something wrong, they've written a software program to come up and say, wait a minute, remember we talked in class about such and such, and you can do that in your Canvas quizzes, give little practice quizzes, and somebody puts B, you say, wait a minute, consider this possibility or whatever. You can do that with practice quizzes. Then the instructor categorizes the error. Then they can keep frequency distributions of the error. Then they go back and teach to that error, and then you start all over again. And in this process, they were able to identify in a statistics class. It's just bioinformatics. It's complicated statistics associated with genetics and stuff like that. And they desperately need a workforce in that area, because it's kind of new and coming up. The problem is that they were noticing that 50% of the class was dropping, including 75% of their female students were dropping the class. They couldn't finish the class. Okay. And so they spent 5 years identifying these 200 conceptual errors. And then in the last 4 or 5 semesters, they've done treatment, where they've done a pretty rigorous treatment assignment, where they do one class the old way and one class the new way. Okay. And y'all want to see how this works? Because they have a little video. This is so fun. By the way, I have never been happier about a publication. This just makes me so happy. All right. So here's a little video on how it works.
Let's say we had students looking at
I know there's a way to
conditional probability.
Is that the way you do it? No.
It's the
There,
other one.
here's how you do it.
We're going to have them work through some real world target problems based on these concepts. So let's say, having provided a basic definition for conditional probability, we then ask them a question about the use of the idea of conditional probability, what you want to know versus what you do know, to a real world problem of a disease test. So a student posed with this question might say something like, the reliability is the probability of getting positive test result among patients who have disease. And then when they compare their result against an expert's answer, they might see a significant discrepancy. And then going further into this, they might be asked what kinds of specific mistakes that are common might have been in their mind. So for example, if the student wasn't considering what was known versus what they wanted to know, they might choose that misconception and then work through additional exercises about how to understand why that's a misconception and how to fix it and indicate whether this actually helped them or not.
All right. Now let's go back to my thing. So cool, huh? All right. You want to see the impact of the treatment? Okay, I did too. I did too. All right, awesome. This is the impact of their treatment. The control was the same as what they always saw, 50% finished, 25% of women finished. Now look at the treatment. I have never in my lifetime seen a treatment effect that big. I mean, I can't even, doesn't that take the breath out of your lungs? Like, this is shocking. It goes from 7% of women are dropping the class in the treatment condition, whereas 25% were finishing before. I mean, you just, in the social sciences or anything that could have that much of an impact. And like, they have a bunch of other dependent variables like grade in the class where they administer the same exam and stuff like that. And they were getting like a mean score of the exam, 70%. Now like the lowest score is 70%, I mean, and it's just astronomical. Like, post-treatment covariates are not going to do anything to the significance of that finding because it's too big, right? The magnitude of the impact is just gigantic. And it's having a bigger effect for women. I mean, all of that stuff is just super freaking interesting. Matt?
So do you think, like, beyond like just helping them better like educate themselves, you think it develops like a more optimistic or more confidence in the students, in the sense that, like, I'm pretty sure like a lot of students like when they take 300 like person individual classes, they kind of acknowledge that like either they're going to pass or fail, and like the teachers may not help as much as they can. So do you think like this kind of system is showing more of a caring side, that we want to see you not just get the answer correct, but we're going to like force you to learn multiple steps, I guess, and it's more
Yeah,
about
like
the emotional outcome?
Yeah, I think it could be a function of confidence, and and it also might be a function of like they perceive that their professor cares, because we, to the extent that we've done research on that, it does have an impact on critical thinking abilities, is when they think their professor cares about them and that kind of thing, but not with this magnitude of the impact. This magnitude of the impact has collected data on what students themselves did not understand and has educated the professors about what they didn't understand. And then the professors can use that information to correct people's understandings. For instance, one study about the visualization of the planets really identified the fact that there was this common textbook that was used that used a two-dimensional way of showing it that caused the misconception unbeknownst to the professors. So my argument is that other professors don't know that students don't know the difference between a fact and an argument. And so when they tell their students to write an essay explaining why something causes something or whatever, and that it needs to be a causal theory and you have to defend it against possible spurious correlation or whatever, they assume that the student knows how to do that. And then if the student doesn't do that, they write them off as being lazy. When really they haven't done the teaching. And really, they haven't been taught what the conceptual errors are because we've never collected data on the conceptual errors. You know, I mean, I've collected the data to the extent that I've administered these quizzes, but they're not human subjects. And so I can't, publish any of that. But I can tell you that students don't understand the difference between a fact and an inference. And my students, when I started teaching this way, they started telling everybody, I had several students start telling everybody that they made a perfect score on the LSAT because of our constitutional law class. And I'm like, well, that's a bunch of bullshit. I'm not teaching anything that's on the LSAT. I took the LSAT, I'm not teaching any of that stuff. Then I look and I notice that LSAT's totally changed and I am teaching that stuff, and and it was because I've written down all these errors. And I guess the LSAT people sort of know what, how can we trip up students or whatever, like the less proficient or whatever, are ways of making sure the legal profession is full of sociopaths. But, they maybe know, but we have not categorized it and we're not aware. And people who grew up smart are not aware of what the B- student needs to be told, And my argument is that we're confusing laziness or whatever with the fact that we're not teaching them, And so like there's a hierarchy to an understanding. You have to understand the difference between a fact and an argument before you can understand and make a causal argument is dependent on imperfect information. And identifying confounding variable requires understanding of what a concept is and what units of analysis are. And, I'm spending more time than I should maybe in my constitutional law class helping people understand that, because there's a difference between legal causality, which is like, did the person know if they smacked their arm that way that the person was standing there and they were going to smack their face, right? Legal causality is more of a fact and it is established as a fact, but that's different from, does this medication work, so to speak, right? And understanding, okay, there could be a modifying variable is different from, oh, it's not going to work on me, right? And all that kind of logic is hierarchical. And so what these people have done is they've established the first most basic conceptual errors. And they claim they had no idea students didn't understand the things that they were collecting data on. Electrical engineering professors had no idea that none of their students understood Ohm's law. And, in physics at our university, they grade your teaching by whether your students are learning. And we've tried to put some of that into existence in our department rather than have it be a popularity test. All right. So in any case, I look at this and I'm like, we have to not do things the way we've been doing them. Like it has to stop that we're assigning essays and giving people who went to good schools A's and fucking over students who weren't prepared, like I was unprepared. And, I can't abide by the ethics of that. And like, yeah, a post-treatment covariate cannot mess with this finding because the treatment is so overlapping with the outcome so as to explain all the variation. I mean, with this magnitude of the impact, our square's got to be at 75. Like they're reducing all of the variation. And of course, people drop the class because they got in a car accident or, but that's the 7%, So it would be 100% without that, like it's just insanity to me. And so, so I can't teach the way I've been teaching anymore. All right. So, and here's an unintentional treatment. Okay. And I'm uncomfortable talking about this because I don't mean to hurt anybody's feelings. So I went to a grad school that was ranked 77th. Our grad school is ranked 30th. So that's better than 77th, right? So the probability that my cohort was going to get that we were all going to get tenure track jobs, what's the probability of that? It's very fucking small, right? You know, and also like we were a sample of the people who, you know, got it, you know, maybe didn't get in anywhere else or so, you know, and that's probably not true and tended to not be true in Houston, but nevertheless. And every other year they had one way of teaching methods, and every other year they had another way of teaching methods. And if you came in even years, you were taught a lot of math, a lot of probabilities, a lot of stuff, like the foundational mathematics before we got into like all the causality and the applied data analysis, okay? The other professor didn't give a shit about math. There was no textbook. That, you know, he walked in every day with a pile of output and we talked about it, you know, and we had readings that were substantive readings and we didn't know shit about math, okay? And now you can tell which one I was in. So the even years, this was the outcome in a 13-year period that this experiment continued. Here were the tenure track placements of the people who got heavy math early on, okay? We had 2 tenure tracks. One person got a 4.4 and the other person was at a 5.5. A few policy analyst jobs and most people didn't finish, okay? The odd years starting, which unless there's something, you know, correlated with whether you started grad school in 1994 or 1995. Here are the tenure track placements, okay? London School of Economics, Michigan State, HBU, me, 2 people at Pittsburgh, University of Strathclyde, University of Glasgow, West Point, University of Colorado in Denver, who's now our regent for, you know, the Colorado system, Adolphus Gustavus, SUNY Purchase, and 5 tenure track placements at UH downtown, and a few community college tenure track, okay? Now, that's a pretty astronomical treatment effect as far as I see, you know? So my argument is fix people's logical bones first, because all of our logical bones are broken when we start grad school. Certainly when we start undergrad, our logical bones are broken. Fix the logical bones. Because I remember like, you know, I was a German major. I didn't know shit about math. And like after I took statistics, I was like, this is fucking awesome. And I started reading calculus book and I'm like, oh, so the whole point is to understand nonlinearities. Like the calculus had a place to sit in my brain, you know, but it was an unintentional treatment. So like, I have an idea of the way I'm going to teach American government is I'm not going to give them hardly any facts. And we're going to test for, you know, we're going to explain, here's some research ideas. And here's the way the science developed in interest groups, or here's the way that constitutions have been analyzed. And here are some problems with the way that was analyzed. And what do you think? You know, what do you think about a confounding variable? And what do you, you know, and how would you reason about that? And give people chances to look at essays and figure out what's wrong. Or like in my constitutional law class, I have a whole essay in the multiple choice. And then they have to identify what the possible legal answer would be given their understanding of the law. It's stuff they've never seen before, but they have to apply that knowledge or whatever, you know. And then what I would like to do is a pre or post CAT test to see if this works, because if it works, that we do better at teaching critical thinking if we do not assign essays, then we've just made TA's lives a lot better, right? Who wants to grade all those essays? Like, it was making me stupider. All right. So let's talk about experiments. All right. In a sense, every study has an underlying unmeasured moderator variables that are constant in the analysis. Is that true or is that false?
I would say probably true.
It's true, right? It's unmeasured and we're not aware of it. So like thinking, is this study 2008 or is it during a financial crisis, you know, or is it during an election year, or is it, you know, like all of these moderating variables that could be moderating the analysis, that the relationship exists because it's that year, like the zero correlation between sex and respect for courts happens to be 0 in 2016. That's the only year in which it's 0, you know? And so there's something about it. And so you don't want to assume zero correlation means it's always that way. Like you always have to keep in mind, what's the context? What's the context? What's the context? Which is why multi-level modeling is going to be so fun. Okay. A person must control for all variables that correlate with Y.
I might get confused with this one and the next one, but I thought it would be false.
It's false. And the next one's false. That's
Okay.
correct. A person must control for all factors that cause both X and Y to be unbiased. Now that's true. And we never know whether we've got them all, and we don't have all the data points. And so we never know, which is why we're always unsure about causality, especially in an observation situation. All right, good. All right, so here I've come up with some fun examples. Here's an experiment. They want to treat SAD, which is seasonal affective disorder. It's when you get depressed when it's bad weather. Depression. It has a random treatment, and they didn't want doctors to pick their favorite patients to be in the thing, and so they randomized it. And they said, okay, the way we're going to do it is we're going to give people the drug in these cities and not give people the drug in these other cities. What could be a confounder there? Well, let me give you an idea. I know here's what we're going to do. We're going to start the experiment in September, and we're going to compare the outcomes in Boulder, Colorado to those in Seattle. What might be a confounder given its seasonal affective disorder?
Well, I would assume the seasons don't necessarily like match time-wise in both Boulder and Seattle. Starting September, you might have a kind of a problem in terms of like the degree of which it's supposed to be, like, for example, like fall at that time.
Yeah. You think like in Seattle, it starts raining every single day. It's dark and dreary. And it's the opposite of that in September in Boulder. And September is beautiful in Boulder. Barely rains, sunny every day. Like you're not going to have seasonal affective disorder. So it's going to make it seem as though the treatment either worked or didn't work, depending on who got what, right? And so the randomization, is not random. They try to control for one thing and they mess it up in this other way. All right, so for which study would undergraduates be appropriate, because we're trying to generalize to undergraduates, versus or generalizable to the entire population, right? So like the impact of a drug on, you can tell I couldn't come up with an idea on that one. I was like, anything that's going to be correlated with age is going to be a problem, right? Where age is the selection factor, and then age is correlated with the outcome is going to be a problem. You've got a selection thing there. Marketing study testing ads for Red Bull. That was just me being rude about young people. And pedagogical studies, like we're, you know, and I hate being rude about young people. So just so you know, it actually, I can feel myself getting angry about it right now. Okay, so and pedagogical studies, we're trying to improve learning. They're the appropriate place to learn. And so I was trying to think like the effect of classical music on mood, or, you know, some of these psychological studies are perfectly legitimate, and others like testing fitness might not be. But if you're testing fitness for a drug that's meant for young people, then it's relevant, you know? And so I always try to have people keep in mind that generalizability to the entire population is sometimes not desirable. It's sometimes not what you're trying to do, you know, in whatever you're looking at. Sometimes, other times you want to be better at it. All right, so what's the wait what? Scholars found, and this is true, they found that if you look at the population of people stopped by the cops are no more likely to kill people of color than white people. Can you think of what the problem with that is? And by the way, the study was published in the PNAS, which is a fancy journal. We looked at our sample. We see all people stopped by the police. What do you know about who is selected into that group?
I guess majority of the people who are being stopped are within like, it's like the traffic stop. So
Yeah, it could be, you know, like sometimes they're often, you know, minor traffic stops. But how are those people different from the rest of the population? Who is overrepresented in that sample?
oh, would it be white people, right?
Yeah,
general-
no, black people. Well, white
Oh, black.
people are, you know, there's more white people
Yeah.
stop. There's more white people stopped, but that's because, you know, white people are 75% of the population, or 70% of the population. But they're 50% of the people who are stopped. Right? So there's more white people stopped. So once you've got them stopped, then yeah, sure, they shoot white people at the same time. But black people, so given that they're more likely to be stopped, that if you select on who has been stopped, you're not figuring into your higher likelihood of being shot by the police. Right? So it's a problem. Okay, controlling for party ID, Black Americans have a higher support for voter ID restrictions than whites. Why? Think about the correlation between being Black and party ID. Like among Black women, it's a constant. Right? At least the vote outcomes. 100% or close to it of Black women vote for Democrats. So once you control for party ID, then you're comparing, you know, Black Republicans to the rest of, you know, like you're controlling for it, then you're going to end up, you're controlling for the factor that makes them less supportive of voter ID restrictions in the first place, right? And so controlling for all of that, then Black Americans who vote for Republicans probably have a white identity, and they're like, I'm not like the other Black people, and you know, then they're like, I'm gonna adopt attitudes that put me in that group more. Okay. How much people hate the other party has a negative correlation with support for political violence. And this is in contradiction to some recent published research, but I've talked to 5 people at Midwest, and they're like, my data shows the opposite, shows what this thing says, you know. So where are we getting this idea that people hating the other party is making people support political violence? And And that's because the way people measured it was already radicalization. But in a way, part of the wait what here comes from the fact that I know I presented to you that this is basically a constant. And so there's so little variation on this variable that it's not going to be meaningful, you know. And so it's not a very good measure. Everybody has affective polarization. All right, so now let's talk about over controlling. Okay, and here we're going to talk about the correlation between mental distress, or let's call it, you know, financial distress, or, you know, some kind of lifetime distress is correlated with whether you supported Trump or Obama. Okay. Let's just say that's true. Okay. So we've got, yeah, I meant to have it be divorce. Okay. So you've just had recent divorce, and it's correlated with the outcome of Obama versus Trump. And let's say it's correlated with racism. Okay. So the correlation between voting for Obama versus voting for Trump and racism is 0.8. Okay. So once you've controlled for racism, there's not much more variation that you can explain with divorce. Okay. But let's see, you try to throw in misogyny, you know, and by the way, women are terrible misogynists also, you know, plenty of misogyny among women, you know, not to say everybody, but as pointed out, the relationship is not as strong as you might think. So if you try to control for misogyny at the same time, and so what's going on? What do you think might be the correlation going on between the correlation between misogyny and the likelihood of divorce? Because it could just as easily be misogyny causing divorce versus divorce causing misogyny, right? It's just like, you know, there might be a big correlation there, but there's also a big correlation between misogyny and racism, you know, and they're both correlated with the Trump vote, and they're both correlated with, you know, and so like you've just got so much multiclinearity in here that you're going to end up over controlling. So if you want to control for racism, it's really going to mess up these estimates, you know, and you don't necessarily want to control for racism here. You know, racism is so correlated with misogyny that, like, now you're looking at the impact of racists who are not misogynists, you know, or the impact of misogyny when you're not racist, you know, and that's not really what you want to look at, right? And the correlation between misogyny and racism is likely spurious, right? They're likely caused by your tendency to believe in social dominance orientation or authoritarianism, or, you know, some other exogenous factor that causes you to not identify with whoever's low on the totem pole. You know, that's the characteristic called social dominance. So you don't want to control for a variable that doesn't cause misogyny, you know. Now, given divorce might, you know, you might want to, you know, you might want to control for that. Now you've got a dichotomous variable, and so now you got all this variation, and they're fighting over, you know, table scraps in terms of variation to explain. And so then your problem has just gotten way worse, because you've got a dependent variable that doesn't have very much variation. So if you have this as a true relationship, okay, well, all right, here's one that I want to talk about. And this is I think, the best article that talks about why you shouldn't control for post-treatment covariates. So here we've got a study that very reasonably wants to study the impact of experience with the civics education course on voting. Totally reasonable causal theory, totally reasonable justification for wanting to teach civics education, right? Like, are y'all on board? One mechanism by which the treatment could cause voting is it inspires people to be politically interested, right? Like, totally reasonable mechanism to, to control for. So they do this, treatment. And then after it's over, they ask people how politically interested they are in the civics education class as compared to the people who didn't take a civics education. They were not in the treatment. Okay. By the way, do we need to take a step back and talk about what a treatment is? Or are y'all good on that?
I think we should be.
Yeah, it's like you tell those people to take the medicine and you give the other people a sugar pill or whatever, right? Okay, so so you're selected in at random. It's not your choice to take a civics education. It cannot be, right? Because you wanting to be in a civics education class is the whole that's the whole banana. Like that would be you're selecting yourself into watching Fox News. So watching Fox News is not a very good variable to look at the correlation between watching Fox News and conservatism, because conservatism causes you to select into that group, right? So that's why it's not a treatment. All right, so so they control for political interest. The problem is where are you getting politically interested? Is it only people who are given a civics education class? Or is it you can become politically interested from your parents or from your friends or from your, like I was working on political campaigns before I could vote. Like I'm a different kind of person and it wouldn't have taken a civics education would have had no impact on me, and if I would have taken it on my own volition, it would have been seen as a treatment factor when it's not a treatment factor for me, right? And so what's happening is the variation of political interest is over controlling for the dependent variable of voting. Do you see how correlated political interest is with voting? And so they're looking at that. And now the treatment is only the orange when the true treatment effect is the entire football. This football, the whole correlation is the treatment effect. And if you reduce that treatment effect by something that happens outside the experiment, thinking that the experiment causes the entire variation, and therefore, we can understand the mechanism, is going to over perceive a mechanism that the treatment is not actually causing. Because now voting is voting if you're not politically interested. Now that's the only effect that the treatment can have. And so it's pretending that the control for political interest is the mechanism. And it is not the mechanism. It explains too much. Now, if you go in and you control for socioeconomic status, which the treatment effect cannot have an effect on, now it's you're voting, but you're poor and politically uninterested, and you're looking at the effect of the treatment on kids who were poor, who are politically uninterested, and so it's they're partitioning the variance such that it over controls for the mechanism. So you've got an independent variable in there that is slicing away at the variation of voting in such a way that now that treatment is now biased downward. Now, in my opinion, what we should do is we should educate grad students to foresee this problem, right? And to account for it in the data, which, you can do without biasing your coefficients. You can say, hey, look, there's a lot of correlation with voting that stands outside the effect of the treatment. So we're therefore over controlling, and you can use instruments, stuff like that. Okay. So we'll talk about an instrument in a minute. All right. So I got a lot going on here, so I have to make y'all disappear. So you got to speak up if you have a question. All right. So I've got all these letters associated with each portion of the variation that is going on here. So, and then what I've done is I've tried to assign a formula that is represented by each of these letters. So the average treatment effect, and they call it the ATE, the average treatment effect, is if you add A, B, D, and H, right? It's that whole football, okay? But the coefficient of a treatment with control for interest is just A plus H, right? That the true indirect effect through interest is B, some of which is explained by D. So once you bring in SES, then you're even reducing the effect of political interest. The appearance, somebody have a question? The appearance of indirect effect through interest is B plus D plus G, which is biased upwards. That is not the indirect effect. The indirect effect is the indirect effect through interest is B and D, but we're going to call it B, D, and G. That's the problem. And look at that G. That is a lot of bias, right? Where the true effect is a B and D, okay? The effect of a treatment that is modified by SES, and modifiers are hard to illustrate with a Venn diagram, but it might be D, okay? So you multiply SES times the treatment, and it might be that the treatment, has a significant interaction with SES that is entirely driven by its overlap with SES and with the overlap between SES and the dependent variable, which is voting, and the amount of variation that SES covers in voting is a lot. And we know that to be true. So the appearance of the effect of the treatment that is modified by SES is included by a treatment modifier is D plus G, which is a lot, All right. But people will say, well, in a model of voting, you should control for interest in SES. And I just don't think that's true. And, people who study voting, even back in the 90s, people were saying you shouldn't control for party ID. If you control for party ID in a model of voting, you've sliced out most of the variation of voting. And now all that you're explaining are how much your independent variables have on the vote choice that is not a function of party ID, right? Each variable is itself absent the other variables in the model. So it's important to be aware of this. Okay, so here's another nice example, and I'm going to bring y'all back so I can see you. Does access to preschool cause IQ? Okay, this is an argument, and in the study that was conducted, they controlled for a mediator called good parenting. I said, giving free access to preschool. I think there was some treatment, some experimental treatment in which they identified some at-risk parents, so to speak, and they gave them free access to preschool. Okay. And then they wanted to know if the free access to preschool, and they had other interventions associated with that. Somebody come to the house, talk to them about parenting, and then they want to control for whether the treatment caused the good parenting, so they control for good parenting. So what do you think? Is anybody a parent on the call? Do you think you're going to be a good parent? Everybody thinks they're going to be a good parent. I thought I was going to be a good,
Scary,
but
but yeah,
I am,
hopefully.
I am not as good of a parent as I thought I might be, unfortunately. And then it turns out that you have no impact on them, and that to me, we have two independent variables that vie for being the most over believed in, or whatever, what am I saying, overemphasized, or and one of them is parenting, and that was in the Freakonomics book, the difference between who parents are versus what parents do. And he had a bunch of variables that kind of matched, like, do you read to your kids versus do you have books in your bookshelf? And it has nothing to do with how much you read to your kids. It's whether you have books on your bookshelf. So all you have to do to have kids is just have books on your bookshelf, which is really just an indication of, are you educated? So you don't actually have to read to your kids. It makes no difference whatsoever in all the data they've looked at. So nothing you do has any impact. So all you've done is agree to have bad roommates for 20 years. Babies are the worst roommates, of all roommates. So in any case, what are the causes of being a good parent? I don't know. I'm in the mood to be snarky. So it's like an appetite for boredom, Oh,
I wonder, like, for causes of being a good parent, then, like, I don't know, because I'm assuming there's tons of books about being a good parent and all, but, like, for the sake of, like, leading to a better IQ of your child, I I don't know, maybe it's like causing the less amount of stress on your child, or like, I don't know. Yeah, I guess.
Okay, I mean that, so first of all, there's a lot of things that you didn't
Yep.
choose, that you were born with, that makes you more likely to, whatever, be patient, and, I can tell you that being financially stressed is going to make you a worse parent, even if you're the best person in the entire world, And so this access to preschool treatment did not cause that variation. There's no way that it overlaps with the cause of that. And whatever good parenting might be, and I don't know how they measured this in the study, but they try to control for the good parenting. And for whatever measure that is it's a shit ton of variation that might overlap with your children's likelihood of having an IQ. By the way, one thing that explains 30% of the variation in IQ is whether you had food to eat that day. Explains 30% of the variation. So that's a lot. Do you know whether that judges who would give harsher sentences at 11 a.m. than they do at 1 p.m.? Before lunch is a really bad time to see a judge. And it's like stuff like that people are not aware of. So in any case, there's a bunch of factors that are causing, there's genetic factors that have to do with intelligence. And there's also like a bunch of factors that are, are just spuriously correlated with these things. And if you control for good parenting, you're controlling for all of that variation. So you're going to swallow the impact of this treatment program, entirely. Okay. So here's an example. So you've got this free preschool. Maybe it overlaps with parenting. Maybe it overlaps with IQ, but you've got all this, supposedly the treatment is independent of SES. It was meant to be independent of SES. So that's why those don't overlap. But the free preschool is overlapping with parenting outside of the treatment, parenting overlaps with IQ outside of the treatment, and parenting overlaps with SES probably more than I'm giving it credit for. And SES is correlated with IQ more than I'm giving it credit for. So if you adjust the impact of this study on IQ, controlling for parenting, it's over controlling and you're reducing the impact by that much. And that's a lot, and you're chopping out all the good parenting out of the IQ. And if you control for SES, in addition to that, even if it's not a function of the treatment, you're over controlling for IQ, and you're reducing IQ to be a function of not being, who you were parented by and whether you grew up poor or not, Now, so when people say don't control for post-treatment covariates, what they mean to say is it's the same thing as over controlling in any context and controlling for correlates of the dependent variable that don't cause the dependent variable, or controlling for correlates that don't cause both the independent variable and the dependent variable, is over controlling in every context. And so you got to learn not to do it anywhere, not just here. And so the 45 articles on this one narrow topic of the over controlling is misguided in my view, and this belongs in data 1, not in 45 peer-reviewed articles. All right, so that's mine. All right, here's a place you can control. Okay. And I promise, because 100 methodologists all agreed with me when I said this. So I was like, we just need to tell them that if your post-treatment covariate, if the only cause of that outcome is the mediating variable is the treatment, then you can control for it. And so here's the place where I was thinking, okay, I'm making this up entirely, that you got these cancer patients and they're taking chemotherapy. And my gut feeling, not ever having been through it, is that people taking chemotherapy don't fucking feel like exercising, right? So they don't, and then this drug comes in that's meant to reduce the effects of chemotherapy. And, that's what it's meant to do. Okay. And it's meant to make people feel better. And then they want to know, do you make people feel better when they take chemotherapy? Are they more likely to live 5 years on? Survival at 5 years is a big dependent variable in the medical literature. That's, one of the things they look at. Like, do you know what survival in 5 years is on breast cancer diagnosis? If you catch it in stage 1. Survival of 5 years is 98%, which means those 2% didn't die of breast cancer. They died in a car accident or whatever, or they didn't get, health insurance, or they, something like that. But they've been diagnosed with breast cancer. They probably have health insurance and they didn't die of breast cancer. So that's an example. So this drug turns out to make people feel better such that they exercise, but not everybody exercises, right? I mean, I'm preparing a short course, so I'm not exercising, or whatever, right? Like that, there's attributes of people that are not exercising or exercise. But if the drug explains 100% of the variation of the mediating variable, then you can control for it. Then it doesn't, the treatment effect is reduced, but you're not over reducing. You're not explaining all, a bunch of variation and survival of 5 years that is outside the effect. So if the treatment causes some Z, where it is the only cause of that Z, and therefore exercise is swallowed up by the variation of the treatment factor, then you can control away for a post-treatment covariate. Then the mediating effect is 100% valid, and the drug still has an impact on survival of 5 years, but exercise explains part of it because the drug made the person feel good enough to exercise. In a way, this is a bad example because some people exercise and some people don't. And so that in real life, exercise would probably stand outside of it. But I tried to kind of make a plausible claim that all chemotherapy patients don't feel like exercising, even if they had the proclivity to do so. And if the drug is meant to make them feel better, then some of those people who take that drug are exercising. And that exercise is part of what explains why they're surviving in 5 years. Are y'all seeing that? So if the treatment is 100% the cause, then you can control for it. Alternatively, if the drug is not associated with exercise, and exercise is not at all correlated with survival, then you can multiply the drug times exercise and see if exercise increases the effect of the drug. Now, is it possible for exercise to significantly interact with with the drug treatment if it doesn't overlap with either variable? This is another conception error that is common. It can. You can have 2 variables that are 100% uncorrelated with a dependent variable, and they can cause a significant interaction. And in fact, it's more likely. But if you've got a moderating effect, then as long as it stands outside of both variables, multiply away. It will not cause a bias in your estimation. By definition, because it's not contributing to multicollinearity. So, by definition, and this is true, regardless of whether it's a treatment effect or not. All right, good. Okay, so here's some weird experimental outcomes. So there was a drug in the early aughts that was invented that everybody was taking called Vioxx. I think it's a Pfizer one, okay? So Pfizer was kind of looking at their data and they're like, wow. So it turns out ibuprofen is really reducing, as opposed to our drug, ibuprofen is really reducing the chances of dying of a heart attack. They say, innocently, when that wasn't the outcome. Vioxx was causing the heart attacks, and the people who were getting ibuprofen weren't dying of heart attacks. The ibuprofen was not protecting them. Ibuprofen was, the sugar pill or whatever that, and Vioxx turned out to increase the likelihood of dying of a heart attack by 8 times or something. I mean, it was terrible, and they knew about it, and they had to bury it in thinking, well, ibuprofen has protective effects of getting a heart attack. It does until you have hypertension, and then it causes it, Another one is kind of cool. It's a study about grapefruit. So here's what they were doing. In this study, they were trying to do a double-blind experiment on the impact of alcohol intake. Okay. What's the trouble with doing a double-blind experiment on alcohol? They don't want respondents to know whether they're drinking the alcohol. They don't want the doctors to know which ones are getting the treatment. How is that difficult?
Well, they would opt into it though, right?
Well, they would be tasting the alcohol when they drank it, right? And then they would be aware they're the ones in the treatment, right? And so they used grapefruit to hide the taste of alcohol. I have been from time to time using grapefruit to hide the taste of alcohol. Like when you are drinking a Greyhound, it sure does go down easy. And so that's what they were doing. And you know what they found? They accidentally found that grapefruit interferes with statin drugs, anti-cholesterol drugs. Because they were giving people these experiments who opted in to statins that were taking anti-cholesterol drugs, and grapefruit makes those drugs not work. And there's a reason for that, having to do with the, CY3PO. I mean, I'm making that up because that's a Star Wars reference, but there's some, mechanism that is also the reason that this like mechanism of your liver using something to clear, the poisons out of your system. There's some chemical in your body that allows your liver to clear out the alcohol. And grapefruit also interferes with that. And it's the same thing that if you take Tylenol, if you're a heavy drinker and then you stop drinking because you got a cold and you take a ton of Tylenol, you might end up on a liver transplant list. It is serious. Now, fortunately for the alcoholics, they don't stop drinking when they take Tylenol, which actually protects against this effect, believe it or not. And it has to do with the same pathway. And so grapefruit will interfere with your body's ability to filter out toxins from your system. But they didn't know that until they started doing these tests where they were using grapefruit to hide the taste of alcohol. And then they end up identifying this other effect. It's kind of interesting. It's a good thing we know that. Okay, are we out of time? How are we doing on time?
We're 7 minutes over technically.
Okay. So I have a few, causal inference slides here. Yeah, see, we almost made it to the end. I have a bunch of blank slides there. We almost made it to the end. So I've got a few things that we'll talk about at the beginning of class. And I have a few, I have a little practice thing. I haven't posted it yet, but I'll post, it's more done than the one yesterday was. Yesterday, I spent 6 hours trying to figure out what R does to run a reliability analysis. I couldn't find any examples of it because all the examples didn't have, like, what do you do if you're trying to call just a few of the variables in your data? None of the examples did that. They were just like, they analyzed the entire data set. And I'm like, I got too many variables in my data set. So I finally figured out you have to subset, create a new data set that's also open, that it only has those variables in it, which I didn't realize. So I have fun with R yesterday. All right. So let me know if you have any questions, and I'll hang on in case you have any questions. And we can get ready for multi-level modeling tomorrow.
Oh, Vanessa,
Yeah.
So last time I got my homework, Joey forwarded to me, but is it okay if I send my email to you so that I'll get in the email chain also?
You're not in the email chain?
No, not yet. So
did
I
that
just realized
happen?
last night, because I never did the Google,
Oh.
yeah, so I can put my email down in the chat.
Oh, no. Okay. Okay, yeah, please do that.
Yeah.
Yeah,
So I
okay.
sent it.
Good. Okay,
So thanks.
all
Bye.
right, take care. Bye.